Factoring, or factorizing, is the process of finding the factors. The key concepts here are 1. Finding what to multiply together to get an expression, and 2. Finding common factor from each terms in an expression. Example: factorize 2y plus 6. Remember the concept here. When seeing the terms in this expression, find out their common factor. Both 2y and 6 have a common factor of 2. If we break them apart, 2y is 2 times y, and 6 is 2 times 3. We can see clearly that 2 is their common factor. So we can factor the whole expression into 2y plus 6 is equals to 2 parenthesis y plus 3. If you see the pattern, when factorizing, basically you are doing the opposite process of expanding bracket. Second example: factorize 3x squared plus 6x. The same concept applies here. Find out the common factor from all of the terms in this expression. If we break apart each of the term, 3x squared is 3x times x, and 6x is 3x times 2. It is obvious that 3x are the common factor from all of the terms in this expression. Therefore, the factor from 3x squared plus 6x is 3x parenthesis x plus 2. Third example: factorize x squared plus 3x plus 2. This one is a bit different. We call this expression a quadratic expression. It's when you want to solve algebraic expression in which the highest power of the variable is 2, and you don't see any common factor from all of the terms in this expression. The key point of factoring quadratic expression is finding the factors of the square variable and the constant. From this example, you cannot solve it using the previous method because there are no common factor for all of the terms. And so, when factorizing quadratic expression, you should use other method. I will show you one of the methods on how to solve this problem. First, break the term in which it has square variable. Here we have x squared. If we break it apart, it is equals to x times x. Second, break the constant. Here we have 2. If we break it apart, it is equals to 1 times 2. The third step is cross multiply them like this. X times 1 is equals to 1x, which is x. X times 2 is equals to 2x. Then you add the result. If you see that the result from the addition is equals to the term in here, then you have the correct answer. And so, x squared plus 3x plus 2 can be factorized as x plus 1 times x plus 2. Remember that factorizing is the opposite expanding bracket, so when you multiply the result, you will get the same expression with the problem. Let's do another one. Factorize x squared plus 5x plus 6. Let's use the same step as in the previous example. First, break the terms which has square variable. In here we have x squared. Second, break the constant. In here we have 6. X squared is x times x, and 6 is equals to 1 times 6. Third, cross multiply them. X times 1 is equals to x. X times 6 is equals to 6x. Next, we add the result. We have a problem here, since the result from the addition is not the same with the terms in here. Then this one is the wrong answer, meaning that we might want to break them apart with different factor. Let's redo this and try to use other factor. First, break the term which has square variable. Second, break the constant. The previous one, we are using 1 times 6. This time, we use 3 times 2. Third step is cross multiply them. X times 3 is equals to 3x, and x times 2 is equals to 2x. Next, add the result. 3x plus 2x is equals to 5x. This time, the result from the addition matches with the terms in here, so we can conclude that this is the correct answer. And so, the factor of this expression is x plus 3 times x plus 2.